Roots and radical expressions. Okay, so first we need to really remember what the definition is when we're taking a root of something, like when we're taking the square root of an expression. So here we have the nth root because we've got more than just square roots. We've got cube roots and fourth roots and fifth roots and so on. So if we're taking the nth root of something to the nth power, it equals x if n is odd. So if n is 3, 5, 7, and so on, any odd index. However, and we really haven't looked at this much when we're taking square roots, it's equal to the absolute value of x if n is even. Because we need to, for example, underneath the square root, we would need to have a positive value, or we're going to deal with complex numbers, and we're going to avoid dealing with complex numbers for this lesson. So you're going to see absolute value bars appear, especially when we've got variables, just because we want to make sure we have positive values underneath even index radicals. Okay, so simply you can kind of remember, you can cancel the exponent with the radical only if n is odd. Otherwise, you're also going to have to include absolute value bars. So for example, let's look at taking the square root of 16x to the 8th power. So our first step, we're going to write each factor as perfect squares. Okay, so here we've got two factors. We've got 16 and x to the 8th, and here this is a square root. Remember, when there's no number there, our index is 2, and so we're looking for, we want to make perfect squares underneath the radical. So 16 is 4 squared. X to the what power squared equals x to the 8th. Well, I can use my exponent laws and take 8 and divide it by 2 and get 4. So I've got each factor, 16 is 4 squared, x to the 8th is x to the 4th squared. Each of those factors are written as perfect squares. Okay, next we will rewrite this expression underneath the radicand as one expression squared. Okay, so I'm just going to combine the 4 and the x to the 4th. So 4x to the 4th squared underneath the square root. Third, we're going to simplify. And the index, in this case, it's 2. It's even, so we need to use absolute value bars when we simplify. So we'll cancel the 2 and the radical, but we're going to put absolute value bars at around 4x to the 4th. Okay, in this case, well, 4 is a positive integer, it's always positive, and x to the 4th is always positive, because if we raise something to the 4th power, no matter what, we will get a positive number. So here, in this case, we can drop the absolute value bars around both the 4 and the x to the 4th. So our final answer is 4x to the 4th. Okay, let's look at a second example. The third root, or cube root, of m to the 9th, n to the 15th. Okay, here our index is 3. Remember, this number that's out here, or the invisible one if we're using a square root, that's called the index. So first, okay, last time with the square root, we rewrote each factor as perfect squares. Here we're going to rewrite each factor as expressions raised to the 3rd power. And we could rewrite this step to whatever power that index is outside the radicand. Okay, so I've got the 3rd root. So I need to take m to the 9th and write it as something to the 3rd power. Okay, well, 9, our original exponent, divided by 3 is 3. So I've got m cubed to the third power equals m to the ninth. Because our exponent laws say when you have a power to a power, you multiply. So our 3's would get multiplied if we were simplifying out the other way, and we'd get m to the ninth. Okay, with our n to the 15th power, I'm going to put my parentheses, what to the third power equals n to the 15th? Well, 15 divided by 3 is 5, so n to the 5th power. Okay, so I rewrote each factor. M to the ninth became m cubed cubed, or m to the third power to the third power, and n to the 15th power became n to the 5th cubed. Next, we'll rewrite as a single expression raised to the third power. Okay, so underneath the third root, we're going to combine the m cubed and the n to the 5th, and that's cubed. Okay, we're going to simplify. Okay, and because the index 3 is odd, we won't need the absolute value symbols. So we can just cancel that third power with the third root, and we're left with m cubed n to the 5th, and we don't need absolute value bars. We're done. Okay, one more example, because not everything is a perfect cube or a perfect cube or a perfect fourth power or perfect fifth power. We might have some terms left over, like we've seen in simplifying radicals. Okay, so we've got square root of 32x to the 7th y cubed. Our index is 2, so we're going to rewrite each factor here as products of perfect squares. If our index is 3, we would rewrite each factor as products of perfect cubes. If our index were 4, we would rewrite each factor as products of perfect fourth powers, and so on. Okay, so 32. Okay, what's the largest perfect square factor of 32? 16 times 2, and 16 can be written as 4 squared. Okay, now x to the 7th. I need to write it as something squared, and I might have something left over. Well, let's think of it this way. How many times does 2, our exponent right here, this 2, how many times does that go into 7? It goes in 3 times with 1 left over. So I have x cubed, so I got my 3, and 1 left over, x, or x to the 1. Okay, I need to address my y now. So I need to figure out what squared and what left over equals y cubed. I'll take my 3 divided by 2. How many times does that 2 go into 3? It goes in once, so y to the 1, or just y. And what do I have left over? I have 1. So I have y, or y to the 1, left over. Okay, so we've rewritten this as the square root of 4 squared times 2 times x cubed squared times y squared times y. Okay, now we will rewrite as a product of expressions raised to the second power, so I'll group them all together, and then we'll have something else there that it's being multiplied by. So I've got the square root of, and I'm going to group my 4, my x cubed, my y. I'll get 4x cubed y, all squared, times what's left over, the 2, the x, the y. So 2xy. So I grouped everything that was a perfect square, and I grouped everything that wasn't a perfect square. Okay, step 3. Here we're going to rewrite as a product of 2 radicals. So we'll actually separate the radicals into 2. My first radical will have the perfect square, so the square root of 4x cubed y quantity squared. And my second radical will have what's not a perfect square, the square root of 2xy. Okay, now we can simplify. And our index is 2, so it's even. We're going to need absolute value bars. Okay, so this first radical, I can cancel the 2 with the square root, but I need to put absolute value bars of 4x cubed y. And then the other radical doesn't simplify because remember they're not perfect squares. So I have the absolute value of 4x cubed y times the square root of 2xy. Now in this, 4 is a positive integer. It's always going to be positive. So I can technically take this out of the absolute value bars. But the x cubed and the y could both end up being negative numbers. So I need to keep them underneath the absolute value bars. So 4 absolute value of x cubed y radical 2xy is my answer.